Hello and welcome back. Let's do a proof. Given the following diagram, prove that x plus y equals z. X, y, and z here. Well, that's another way of saying that we need to prove that the measure of an exterior angle of a triangle is equal to the sum of the measures of the two opposite interior angles. Okay, let's write our thoughts out to the side and see what we come up with. So we can see this is a triangle here. And we know that the sum of the measures of the interior angles of any triangle equal 180 degrees. So that would look like measure of angle x plus measure of angle y plus a measure of angle w. I don't know why I wrote it in that order. That's okay. Equals 180 degrees. What else? Well, we can see this is a straight line. So this is a linear pair, and linear pairs form supplementary angles. That will look like measure of angle W plus the measure of angle Z equals 180 degrees. We want to get to x plus y equals z. We want this to be equal to this. Well, since both of these equations have this in common, let's rewrite both of them in terms of what they have in common. So that would be measure of angle W is equal to 180 degrees minus the measure of angle X minus the measure of angle Y. So it's like we did minus the measure of angle X on both sides and minus the measure of angle Y on both sides. Similarly here, measure of angle W is equal to 180 degrees minus the measure of angle Z. It's like we did minus the measure of angle Z on both sides. Okay, let's step back and start writing in our proof. Well, we can start right here actually. Number one, measure of angle, let me go in order here. W, measure of angle X plus measure of angle Y equals 180. Triangle angle sum theorem. Which again tells us that for any triangle, the sum of the measures of the interior angles equal 180. And then what? Oh, we also saw this. We know that's true. Measure of angle W plus the measure of angle Z equals 180 degrees because linear pairs form supplementary angles. And then what did we do? Then we did this. So we have the measure of angle W is equal to 180 degrees minus the measure of angle X minus the measure of angle Y, and that the measure of angle W is equal to 180 degrees minus the measure of angle Z. That was just a subtraction property of equality. Okay. So if we have this is equal to something, and this is equal to that same something, then it must be the case that these are equal to each other. That's what transitivity tells us. So let's write that down next. So we're going to put these equal to each other by transitivity. 180 minus the measure of angle x minus the measure of angle y is equal to 180 minus the measure of angle z Okay, let's do minus 180 on both sides. That gives us minus the measure of angle x minus the measure of angle y is equal to negative minus the measure of angle z. Subtraction property of equality. And note, we want to get here. Those are all positive. We can just divide every term by -1. That's legit. And let's write out what we have. That was legit by the division property of equality, which tells us that if we divide both sides of an equation by a non-zero number, we have an equivalent equation. And we are saying the measure of these angles, that the sum of these two angles is equal to this angle, which is what we were supposed to show. So we're done.